I will present the deep learning models to estimate and predict the solar irradiation in Brazil. So you can see the end in the final first line, because we create two models. The first one to make a kind of regression, and the second to estimate, to create a time series to preview the future solar radiation. So the motivation of this work is because the backbone of the photovoltaic power technologies needs to be measured, and it's necessary to have quantization about this quantity. And solar radiation can be difficult to detect because the parameter is expensive, it's hard to find in everywhere. I don't know, Brazil certainly is hard to find. The high cost is on the most points that we have problems to have solar weather stations. So many research have been applied to detect, to preview the solar irradiation, but all these works, I try to detect only on a specific region, but in this work we try to make a generalist model that we try to detect everywhere in Brazil. So Brazil is a big country, all you know about this. So we have work in Brazil like Fortaleza, Seropédica, Petrolina, Botucatu, among others that can say about the solar radiation in specific points. But now we try to detect in a generous model the north to south part, east to west part. So in this way, we can try to create a deep learning model as a regressor to estimate the solar radiation, and after we create a dynamic model to estimate the future about the solar radiation, the time +1. So the first model you can see in this pipeline is sorry in this pipeline diagram. So we have a big data set from the Brazilian Meteorological Institute called the INMET. In there, we have more than 1,000 weather stations, and we select some features here to make the training stage of this deep learning model. And we have also a weather station that we create in the university. With this weather station, we have parameters, but it's expensive, we will try to avoid. So we have using also this data with the radiation, create the model of the deep learning to create the prediction, the regression of the solar radiation. In the second model, we have also the INMET data set with solar radiation. So in this point, we don't have more than 1,000 weather stations. We have only 606. So we have to remove some weather stations that don't have solar radiation. Or we can also use the first model that we have the regression, the value of the solar radiation predicted from the first model, and plus the geolocalization and the date to create a model using the long short-term memory. It's a time series, is a recurrent neural network. And after we have the next minutes, hours, or days is so difficult to find, but we try to have a model for 1 day. So for the results, we have the data collection from these 606 meteorological stations. You can see this map, the Brazilian map. We have some island here, but you can see some places that don't have a lot of weather stations, but it's possible to find in almost parts in Brazil. This data set is gathered from more a decade, starting in 2010 and to 2022. And the total of the quantity of the weather data is 36 million more than of samples. We try also to remove inconsistency, you make the data cleaning. So the rest of good samples is more than 36 million. The first model in the is before a black box, now is a gray box. We have 6 features in the input of the deep learning model. These 6 was selected before from a feature selection using the filter. We have used the Pearson correlation. And the 6 features here is used as input of this deep learning model with 24, 78, 32, 20 neurons for each hidden layer. And we have the output layer on a linear output. So these values was found using the grid search. It's an exhaustive grid search. We took a lot of days to find this information. So I present here 2 results of this model. The first we have using the weather data from Bauru in the state of São Paulo, and we have the time, temperature, humidity, pressure, wind speed, and precipitation. We have only 1 day with rain, and here we have the ground truth. The red line is the ground truth, and the blue is the regression of this model. We can see that it's okay, follow in a good way, but have some problems like here, because in the cloud days and rainy days, the model does not perform too well. But our purpose is to find the solar radiation. So it's okay, but we have to improve this model in the future. In here is another weather station. Sorry, the previews have a resolution of 5 minutes. And here is a resolution of 1 hour. And our model also try to find a well. Here it's a good one, but you can see some delay here. Maybe it's a generalist model can try to find some problems because Brazil is so big. For example, in the north part, we have a sun, and the south part we don't have sun at the same time. So it's not perfect, but we'll try to fix also in the future. In comparison with other models, our model is best for the mean average error, but the train is so expensive, more than 74,000 seconds. The sport vector machine is best, but we have a lot of data. Obviously, we have also, after the training, the test set, our model is third, and it's not the worst, but not also the best. So here, we can recommend our model or the multi-layer perceptron, the conventional, because the time here is the best, or the second best, sorry. And here, the mean average error is close to our purpose. And the second model is a recurrent neural network that have this kind of characteristic. The output come back to the same model. So we have a kind of memory, long short memory is the name. So create some gate of forget and memories, etc. And our training converts after 18 epochs. And here we have some results that you can see. We also have the ground truth, but we make the prediction and compare with the real values. And the model follows well, but here no. This day is like the same in Xanxerê, the second result of the first model. But we try to detect the solar radiation. The values goes down, but not in the perfect way. So we have also make the comparison with methods, sorry, and the LSTM have the best value for 30 minutes, 6 hours, and the Kalman's filter is the best for 5 minutes and 1 day. The ARMA, autoregression and movie average have the best value for the test, and the multilayer perceptron goes worse in this condition. So we can recommend our method for the next 30 minutes, 6 hours, and Kalman filters goes better in 5 minutes and 1 day prediction. So our findings demonstrate that we can use the DNN model to create this generalist model, but have some problems. We have to create a balance of data, and also we can try to make some self-attention topologies in the future. And also we have indicated the potential of deep learning-based models to estimate in Brazil. But we have to look at the, other situations, like the type of weather in some places. For example, Amazonia is so rainy. Here it's more or less. In the Northeast is dry. So we have to make some more considerations or some more features. So it's my presentation. Thanks so much.
Thank you for the excellent presentation. Is there any question from the audience?
Actually, I have several questions, but thanks for a very, very interesting presentation. My first question is, when you talk about solar radiation, it's a shortwave radiation. But why don't you consider direct diffuse radiation separately? Because when you the next step would be to see the solar energy production, which that's here the solar. So it makes sense to, I think, to split the solar radiation into direct and diffuse. So that's my first question. My second question, if you allow, is when we do solar power forecasting. It's you took the humidity and so on, but we tend to take the ozone and aerosols and so on in the atmosphere because that's what, is on the way from the sun to the earth, right? So why didn't you consider this type of input variables in your forecasting system, but only surface-based? Correct me if I'm wrong, but that's how I understood.
No, you are right. Thank you for the question. Our model is try to create a part of a virtual power plant. So you try to detect the radiation to preview the conditions of power plants in the future, solar plants in the future. But we try to perform better our model. We can try, but I agree with you about this. So yes. Thank you.
Okay, thank you. Is a triad? I hope so. Is there any more question from the audience?
Yeah.
Any more question? Okay. Sorry, I didn't saw.
Thank you for a nice presentation. Could you try to take the map where you show all the existing weather stations? I was just wondering if you had, clustered your weather station or grouped them somehow, or if you would see a difference in how accurate models you would get, whether you were close to equator or whether you are all the way down here in Sao Paulo state, if there's any differences in how accurate you can predict.
Yes. For example, it's hard to rain in the the northeast part, for example, in Amazonia, rain a lot. But we try to make a generalist model to in the future. We don't have intention to use all these weather stations. So we have to create a points in Brazil to estimate better. So we also consider the geolocalization in the second model to perform better this prediction. So yes, it's a huge country. Sometimes snows in Rio Grande do Sul. In the north part, have a lot of rain, or in another part, no. We have to consider the geolocalization to make better our model.
Maybe a second question. Another thing I was wondering, because weather stations have a certain cost. So in all those areas where, you don't have a weather station, had you considered that you might be able to, make a virtual weather station based on the weather stations in the surrounding? Such that you could get a finer grid of predictions for the installation of PVs?
Yes, I think it's a good idea, because here, for example, it's so far the next weather station. So we can try. Here in the Amazonas, I think it's so hard to put models, but we can try using the near points here. But here, I think it's possible to also maybe invite someone to try there also. I think yes.
Thank you. Thank you for your excellent defense and presentation.